Hello, my friends. I'm Clover. Mom, if you're watching this, yes, I probably should have remembered to brush my hair before starting this recording, but here we are. We're doing it live. We're going to be solving two classic Sudoku by Philip Newman today. These were originally posted in GAS on March 6th, 2024. These are both standard classics, so in both of these puzzles you're going to see in this video, we're placing the digits 1 through 9 once each in each row, each column, and each outlined 3x3 region. My understanding is that the first one is a little gentler and the second one is a little bit spicier. Unusually, I actually have not solved these already. I did not test these before they appeared on the channel. Bill and Backpow tested them. So this is going to be essentially a blind solve for me. And so I'm just going to narrate what I'm seeing live as I encounter these puzzles for the first time. So let's get started. So this first puzzle is called Sequence Snake. And the first thing I notice is that I have all of these just delicious sets of 5 filled cells in a single region, and I'm going to start with each of those. So here I have 1, 2, 3, 4, and 5. I need to place a 6, which can only go there. This cell can only be 9 because there's a 7 and an 8 in the column, and my remaining cells will be 7 and 8 in some order. Here I have 5, 6, 7, 8, and 9. I need to place a 1, which can only go in this cell. I need to place a 4, which can only go here, and the last two are going to be 2 and 3 in some order. Here I need 1, 7, 8, 9. 1 can only go there. This can only be a 7 because there's an 8 and a 9 in the column, and then these cells are going to be 8 and 9. Here I'm going to need 1, 2, 3, and 9. This can't be 1 or 2. These can't be 9. Those can't be 3. Oh, 1 has to go here because there are 1s there and there. So I need 2, 3, and 9 still. That will have to be my 2. That's my 9, that's my 3, and that's going to resolve the 8, 9 pair. Now I have 4, 5, 6, and 7 to place here. This cell can only be 4 because I have a 5, 6, and 7 already. 7 can't go in those cells, so it goes here. And 5 and 6 are resolved. The 7 also resolves that 7, 8 pair I placed earlier. Here I'm going to need a 3, 4, 5, and 6. This cell can only be a 6 because I have a 3, 4, and 5 here. So that one can only be a 5, and then these are going to be 3 and 4. And now I can fill in some of the initially less full regions. Here I need a 1, which can only go there, and my last cell is going to have a 4. Here I need a 5 and a 6, and then my last cells here and here are going to be a 9 and a 5, respectively. I need to place a 3 here, and I need a 9, and then to finish this region, we're going to put a 2 there and an 8 there. Here I need a 1 and a 2 to finish the region, and I also need a 7 and an 8. We just have one region left to fill in. 3 and 6 will go there and there. 7 and 8 will go here and here, and I need 2, 4, 5, and 9, which will go into these cells. And that is how you solve Philip's nice and gentle Sequence Snake classic Sudoku. Let's move on to his second one from the same day. This is called Shuriken, and this is also a standard classic Sudoku. Let's have a look. I'm guessing it's called Shuriken because often puzzles that have this sort of 4-way rotational symmetry pattern, they resemble like a throwing star or a shuriken. So this is Philip punning on the term shuriken. So this, just off the bat, I don't have as many regions that are quite as friendly looking as in the previous puzzle. I do see that I'm going to have a hidden 6 in region 1 because 6 is ruled out of these cells by the rows and this cell by the column. I'm wondering now if I get some symmetry out of that. I have 5s here, I have 2, okay, I have 2s here which rule 2 out of those cells and give me a 2 in that position. 3s here which give me a 3 in this position, 4s here which give me a 4 in that position, and 1s here which give me a 1 in that position. So that looks like what Philip intended us to notice first, for sure. So what do I still need to place in this region? I need 2, 3, 5, and 7. 5 can only go here. This can only be a 2 because there's a 3 and 7 in the column. And so these are going to have to be 3 and 7. I don't know the order yet. Can I do something similar in the other regions? So what I notice when I'm looking at this region, actually, is that this column, which intersects with that region, is getting pretty close to being full, and specifically the 6 and 7 in this region keep me from placing 6 or 7 here. So my 6 and 7 in column 7 have to go into these cells, and the remaining digits in that column are 8 and 9. These are now going to be 1, 4, and 5. And And normally I wouldn't mark that, but I'm just going to go ahead and do it because I had the thought and I don't want to forget it later in the solve. Now what? So here, oh, I'm seeing now that I have 2 7s here, which will give me a hidden 7 in region 8. And that makes me think, because it's Philip, that there probably is going to be some other symmetry going on. And I see that I've already used it here with these 6s. These 5s I've also already, well, let's see, because I think that the symmetry, if it is there, would give me that cell, but it doesn't seem to. How about over here? So 8 in this column has to go there, and then my last cell here is going to be a 9. And if I look at these corner boxes that are kind of filling up, what do I need to place here? So these are going to be 3, 4, 8, and 9. The 4 goes in one of those cells, and it can't go here because of the 1, 4, 5. So these will now be 3, 8, or 9. And that one isn't 9 because there's already a 9 in the row. So now I need a 2, a 3, and an 8 here. This can only be an 8. It's a naked 8 because there's a 2 and a 3 in the column. So that's that taken care of. Now, here I have 8s that see most of region 5, so I'm going to place an 8 there. That's the only position for 8 in region 5. I have 1s here that give me a hidden 1 in region 8 down here. I have 2s here that tell me there's a 2 in one of those, but I don't quite know which yet. What if I look at this row? So that's not a 1. These are going to be 2, 4, and 5. And so now that's a naked 4. Perfect. And so now I just need 5 and 6 to finish this region, and that's taken care of. So now these are going to be 5 and 6 to finish the row, and then 1 and 2, and their order is not known yet, but we will get there. In this column, we need 4, 6, and 7. So that's just going to be my 7. And here we need a 4 and a 6. And to finish this region, we'll need 3 and 9 in that order. These are going to be 7 and 9 to finish the column. And now we need a 4 in the region and we need a 5 there. Now, what do we need to place here? These are going to be 1, 3, and 9, and that's a naked 9 because there's a 1 and a 3 in the column already. And then we'll place a 1 and a 3 here. Now, in this row, what do we still need? We do still need an 8, which can only go there because there's already an 8 in this region. And now this will be 1 and 5, like that. And that will resolve all that good stuff. And then I think everything is just down to having a single digit in a row or column. And we are finished. And that's how you solve Philip Newman's Shuriken. Those were 2 lovely classics. Philip was correct. The first one was a little bit gentler than the second one in terms of just having more regions already nearly completely full. I personally find that seeing region logic is often easier for me just kind of on the fly than seeing row and column logic, and that's probably a lot of why the second one felt more challenging to a lot of solvers. But I hope you enjoyed those. Hope you enjoyed seeing a little bit more of a blind solve. That is maybe a little bit more what the solve would look like if I was actually encountering this, for instance, in a speed solving contest. Appreciate you guys watching. If you haven't subscribed already, go ahead and give us a sub, give this video a thumbs up, and I will see you next time.